Hi, my name is Vineeth. I'm a PM that works at a startup called StatSig. I wanted to share a quick bit of context of how I got here. I used to work at Microsoft and moved to Facebook about 4 years back. When I moved to Facebook, I worked on video infrastructure. I felt like I learned a new way to develop software. Leaders set direction, teams figured out what to do, and measured progress frequently. Teams didn't need leaders to tell them when they were on the right path or not. They had the feedback loops to learn this themselves and self-adjust. It was incredible to see the power of self-directed teams operating independently towards a shared mission to make video better. As I spent time there, I learned more about the culture and the systems that made this possible. StatSig was created to take this insight and create similar experimentation tools for everyone else. There's a lot of talk about building data-driven culture and empowering teams, but very little about the systems and the infrastructure that make this possible when working with video. Today, that is the curtain I want to pull back and show you. Many disciplines start as art and evolve into some blend of art and science over time. Marketing was once dominated by brand advertising and creative on TV, with little way to connect cause and effect. Today, though, this is driven by performance marketers who can measure the effectiveness of creative campaigns and measure down to things like customer acquisition cost and lifetime value. I stuck a Mad Men reference here because without them, the current generation has trouble imagining marketing as once mostly art. You certainly don't see that today. Sales was once defined by schmoozing and playing golf, but sales operations now makes it easy to measure. If you ask any sales team who the most productive sales rep was last quarter, it'd be trivial to answer that. But if you ask most product teams what their most impactful feature on KPIs was last quarter, they'd struggle to answer that. They may tell you what feature they like the most, but that's not the same as impact. Product development is still in early days of transitioning from art to science. Product development feels very much like art right now. At planning cycles, I love pulling these animals out. Everyone has worked with a hippo. It's usually the highest paid person's opinion, and without data, that's often what teams gravitate towards. But really, the future is here, just unevenly distributed. Companies like Facebook, Uber, Etsy, Amazon, Spotify run 10 times the experiments most other companies do, and I want everyone to be able to do that. I wanted to share a story from when I started working on video. Video is particularly great for experimentation because it's really hard in the real world. You're trying to squeeze as many bits as possible through networks that are congested. You're often trying to use a lot of CPU on devices that aren't very capable. Everything works really great on your phone on a great network, but when it meets the real world is when you actually learn what works and what doesn't. This example also involved me being humbled because my initial intuition was wrong. I was working on video ingestion, allowing users to capture and upload videos from within an app. When we uploaded these videos, we had to make trade-offs between the bitrate, reliability, and latency. The better the visual quality, the larger the upload, and the longer it took. This increased the probability that it would fail. Conventional wisdom told us that once visual quality was good enough, there was little point in making it better. We thought we'd found this point for the app we were optimizing when we started working on short-form video. This is, after all, the TikTok age. Short-form video was new then, and barely anyone used them within the app. I still remember the conversations with an engineer who was passionate about making video quality better on these because short-form video was a key bet for us. Both the engineering leader there and me were reluctant because we'd bought into the conventional wisdom that improving visual quality from where we were wasn't going to do much for our users. The engineer had enough passion that he actually built a prototype in a week and increased visual quality. When he shipped it to a small set of users, we saw latency increase and reliability drop. But interestingly, we saw people engage with these better quality videos more than the videos without this better quality. Consumers could see the difference and valued it. When he saw this, suddenly the engineering leads and me were very, very interested in this. It was easy to recruit support to invest in fixing the reliability and latency issues because we knew our users cared about this better visual quality and were responding to it. Without experimentation, the engineer would never have gotten the buy-in to convince anyone to invest in improving all three because of how much of the team's resources it required. Here, now with data, it was an easy decision to make. Short-form videos are typically consumed full screen on the phone, whereas most prior videos played in a small box in the app. It made sense that users were more sensitive to visual quality here. But with many experiments, in hindsight, the insight is obvious. This experience was humbling because the leads here were clearly wrong. Finding a way to test an idea quickly and cheaply, and doubling down when we realized that we were impacting what our users cared about, allowed us to move fast. I came away with an appreciation of how powerful a tool experimentation is to learn from our users. Over time, I've gotten to work with experimentation on video at Facebook and now with a bunch of customers in my current job at Statsig. With great teams, experimentation on video is ubiquitous. It is so ingrained in how they build and ship software that they often don't realize they're experimenting. Every single layer of the stack builds new features, ships them to users as A/B tests, and captures the impact on metrics before deciding whether the change is good for our users. I won't drain every example here, but this is illustrative about how every layer of the video stack, from product and UX to the network protocols that we use to deliver video, are constantly evolving because of experimentation. At any given point of time, there's probably hundreds of video experiments running on most of the successful video apps. Two that are interesting here. Sometimes cached video is very low quality because it was cached when the user was on a very poor network. If the user plays it when they're on a better network, they now have Wi-Fi. Should we discard what we have cached and re-download it? This is the classic case of a bird in hand versus two in the bush, where we're trying to manage risk and determine which is better in the real world. We found our way to the right balance here by experimenting. Another example of where we found success is with switching to more efficient codecs and approaches to encoding. This often requires an iterative approach, where there's a class of legacy devices where new encodings don't work as well, and finding and adding them to a block list allows us to ship goodness to the vast majority of users. It sounds easy, but video is dependent on so many complex interactions that we're sometimes stumped with what we learn from our experiments. Here's an example of what happened when we tried to roll out more efficient encodings. We created new encodings that were slightly better visual quality than the old ones, but were still smaller than our typical encodings. When we started rolling it out to a small set of users, we were expecting to see our video consumption metrics get better. Instead, what we saw was our metrics nosedived. The time it took to start playback went up. People watched less of this video. Sure, video quality was better, but the negative metrics were unexpected. Part of what differentiates product experimentation from a simple website optimization system is a holistic picture. You can explore the impact on metrics outside of the core metrics you're expecting to move to understand the full impact of the change you're making. When we looked at CDN metrics, we saw that the test group here had a cache hit rate of about 20%, while the control group, the cache hit rate was about 95%. Because the new encodings were rolled out only to a small set of users, the number of requests was relatively low compared to the legacy encodings, and our CDNs were caching the legacy encodings really well, but not so much the new encodings. To make this experiment work, we had to create a new control group where the cache hit ratio was similar to our test group. We did this not by creating a new encoding, but by adding a cache breaking key to our control group's videos too. Now, we had a test group and a control group with very similar cache hit ratios. The moment we did this, we started seeing in the real world the results we were hoping to get. Our more efficient encodes were indeed showing better video consumption metrics, but more importantly, users enjoyed them more and engaged with this content. So why do many companies not run hundreds of these experiments like we're talking about? Part of the reason is this is the old way of doing experiments. This is what many companies are doing today. It's expensive to do, so they do very little of it. As I talk to more and more customers, one thing is clear. Most of the literature out there for product experimentation is just plain wrong. The recommendations are often theoretical, academic, and outdated, leading teams to believe in a false sense of precision, and they waste months waiting on a handful of experiments. Large companies like Spotify, Airbnb, and Amazon have gathered over the years a practical tribal knowledge to running experiments. Carefully tweaking the traditional academic recommendations can lead to 10 times more parallel experiments, leading to significant speed up in product development. The modern way of doing this is so simple that every single change ships as an experiment. How do they do this? By not explicitly creating something called an experiment much of the time. What they effectively do is every single feature change is built behind a feature gate. This feature gate lets you control who sees the feature. These feature gates enable progressive rollout. You can start by rolling it out to 1% of your user base and gradually ramping it to 100%. When you've rolled it out to 1%, you actually have two buckets of users. Your 1% are your test group, they're getting the new feature. The 99% that aren't getting the new feature yet are your control group. Every time you ramp user traffic, the systems automatically present a view of all the impacted metrics, comparing these two buckets of users, the test and the control group, that were automatically set up. You can see the trade-offs your feature is causing and determine whether this is the right direction for the change you're making. We often make these decisions today, except we're unaware of them. These tools help make you aware of them. It also lets you get everyone on the same page because it gives you a common language to measure progress and impact. Again, every change is shipped behind a feature gate. This is rolled out progressively, very gradually. Just doing this automatically creates the experiment. No need to define hypotheses, recruit cohorts for control and test. And automatically you have a holistic full picture view of all the KPIs, so you can recognize unintended consequences. One last slide I wanted to leave you with is the most common myth I hear about A/B tests. It's that you need Google or Facebook-like scale to use experimentation or A/B tests. A surprising thing is that small companies actually have a huge advantage when it comes to this. If you work at an Amazon or a Google, you're often looking for metric improvements in the 0.5% range on a well-optimized problem. To measure this accurately, you need sample sizes in the millions. When you're a small company, though, you need much larger wins. You're looking for the 10% wins, the 30% wins. Getting a 1% win repeatedly will never amount to much. The more significant the impact or the effect you're trying to detect on the metric, the smaller the sample size you need is. Trying to detect something that's a 30% change on a small conversion rate, you'll need about 5,000 users. If you wanted to detect a 1% change effectively on that same conversion rate, you need about 5 million users. This is a screenshot from a small live audio social network that was experimenting on StatSig. They were experimenting with new user badging, identifying these new users to others so others could be more welcoming of them. They had about 1,000 daily active users and had statistically significant results after a day. They found the change positively impacted the experience, even in areas they were not expecting. They had insane lift, and not every change is like this, but you get a sense for how powerful and fast this can be, even for a small company. Seeing companies like this find success with experimentation is what brings me into work. I mentioned I work at a startup called StatSig. We're a bunch of ex-Facebook engineers that loved the tools that enabled us to move fast and learn from experimenting so much that we left Facebook to recreate these tools for the world. I can nerd out for eons about experimentation. If you have ideas that you want to talk about, questions, or just cool stories to share, I'd love to hear from you. Always happy to chat about experimentation.
Hey everyone, we're back. Joined with Vineeth from StatSig. Hey Vineeth.
Hey Adarsh, good to be back. It was kind of fun to watch some of the people talk earlier. It was kind of funny how across live streaming, reliability, transcode, and even understanding, like experimentation seemed like a theme that all of them use implicitly to kind of figure out how to do stuff. So yeah.
Totally, yeah. I think it's a great topic to talk in an at-scale conference because, when you're working at scale, experimentation is one of the best ways to actually roll things out. And with that, actually, this rolls into one of the questions I have here, or actually two of the questions. I can kind of merge them. One of them is kind of just a little more exclamatory. It's like, were you being literal when you said you can ship every change as an A/B test? And then the second question, which is pretty much a similar thing, but more of an actual question, which is that with the purest experimentation model, right, that leads to a very highly iterative approach. And so how do you think about that with bigger changes, things that may take longer to build out and actually show an actual impact?
There's probably two parts to kind of answering those two questions. The first one is literally like many of the places that want to experiment that don't experiment as much as they would like to. Often the challenge is the cost of each experiment is high. It takes time to set up, and people in the data team need to kind of construct pipelines, dashboards for each experiment. And part of the magic that some of these big companies have figured out how to do is basically to make the cost of running the experiment as close to zero as possible. So literally you build your feature, start to roll it out gradually, and the system automatically figures out, hey, there's a set of users that get the new feature, people that aren't getting the new feature, and implicitly kind of presents you with the analytics for it. And that's kind of how literally every change, yes, can be shipped as an experiment. But the flip side to this is, being able to experiment is not a replacement for good judgment. So part of building product is still bringing good judgment because, part of what good PMs do is kind of figure out what are the right things to kind of explore. The cool thing about experimentation is you can rapidly try a few different ideas without going all the way and see whether your users care about that. And that helps you quickly narrow what to double down and invest on. But it's not, you don't spend all your time trying all the possible variations that you might consider because, it isn't a substitute for good judgment.
Yeah, it makes sense. It doesn't completely take the human element out of it. You can't just throw everything at the wall and, well, I guess you could, but it probably wouldn't lead to the best user experience.
Which is why I think good product building is probably some combination of art and science. it probably will never be pure science, but you want that combination of art and science, not just art, not just science.
Makes sense. Yeah, experimentation kind of as a tool to help validate and move fast on the actual product decisions themselves. Makes sense. Yeah, following up here, I think the next one is, how many experiments typically give you the results that you're expecting?
This comes back to some of that judgment we were talking about. My general sense is a third of the experiments that I've typically been involved with, I actually get the results that I'm expecting out of them. Roughly about another third tends to be negative. I thought it was going to be good for our users, but for some reason, it's not. And there, even if we iterate and play with it, we can't actually unlock the value we thought it would have. And the best thing we could actually do is turn that feature or shut that thing off. And then there's probably the last third that requires iteration. So you expect that when you ship it to your users, they're going to see better video, they're going to engage with it more, they're going to share more of it. But on the first try, that you don't get the metrics lift that you're expecting. And often that's where you spend a bunch of your time trying to understand, why did users not get that value? So we talked about an example where CDNs were getting in the way. We'd shipped a new encoding. It was still a small percentage, and CDNs weren't caching it the way they were caching the legacy encodings. So trying to understand and iterate on that tends to be what's required to kind of unlock the value. The cool thing about experimentation, though, is you can kind of figure out what buckets your features fit in and actually figure what to do. When you don't have that, all three classes look about the same.
Sense. And following up from there, this is more of a comment, or it's a comment followed by a question. I'm surprised that small companies can use A/B testing. Isn't that just for the YouTubes and Netflixes? Can you tell us a bit more about how that works and why more people don't know that?
Sure, happy to. It's probably one of the most common myths that I get to hear when I'm talking to people about experimentation. I think part of the reason why the big companies are associated strongly with experimentation is because they often have the internal tools and systems that kind of make experimentation easy. But the flip side to being a big company is they've often optimized many of their metrics tremendously. So when you're looking at trying to measure a 1% or a 0.5% change, to measure that with precision, you need literally millions of samples. And that's what large companies are often battling with, which is why many of the experiments you hear from large companies tend to involve millions of samples. With small companies, though, they're not looking for a 0.5% lift. A small company is not going to get big, making those tiny little incremental changes. And the cool thing with experimentation is if your minimum, if the effect you're trying to detect is like 10, 20, 30%, the sample sizes that you need are much, much lower. And I think I'd mentioned some specific numbers, like a 1% change on a 5% conversion rate. You probably need about 5 million samples to measure that accurately. On the same conversion rate, if you have a 30% change, you need like 5,000 users. And yeah, small companies, the ones that grow, clearly are driven by experimentation.
That makes a lot of sense, yeah. One more question I see in the chat here. Well, it's kind of a comment and suggestion perhaps for StatSig based on it, but I think I can kind of make it into a question somewhat, which is from Jim. It's basically about how do you compare results? It says here, you showed mean and standard deviation, or perhaps median and perhaps P10 and P90, but wouldn't it be better to look at things like histograms? And I think I'll paraphrase it there and just kind of make it into a question of like, how do you go about comparing the results of experiments?
It's a bit of both. So often when you want to look across a broad swath of metrics to figure out what you should look at, you want to be able to look at means because it quickly allows you to summarize data across a number of metrics. But once you want to drill into a specific metric, often what you're looking at is either a histogram or a percentile distribution to understand, because not all users are going to move with your mean, and being able to break that out specifically is super useful to understand. So, yep.
Totally. I don't think we have any more audience questions coming in. Did you have any final thoughts or things maybe you thought of that we didn't get to earlier, or?
Like spending today morning listening to some of these sessions, the one thing I was reminded of was like, I can't wait for a few years from now when we A/B test doing something like this with a metaverse-like experience versus this experience. And like, I can't wait for that world where it feels like we're actually together in the same place, even when we aren't.
That's great. Thanks for the plug of the metaverse there. Well, with that, thanks so much, Vineeth, for ending us off here and for your great talk about experimentation. Really appreciate you taking the time, preparing the talk, and coming in. All right. And with that, I am sorry to say that does it for today's scheduled talks. So to recap, I mean, today we kicked off the conference with 6 great talks talking about everything from, challenges in learning with live streaming architecture at scale, content provenance and video understanding, and finally the experimentation talk we just heard. So big thanks to all of our speakers for volunteering to share their learnings and joining us today. And thanks to all of you out there who submitted questions for Q&A. That really made it a lot more interactive, in this age of virtual conferences and remote conferences. And then thanks to everyone else for attending day 1 of Video at Scale. Be sure to tune in tomorrow, where we have yet another great roster of speakers, and we'll conclude with a live speaker panel on audio quality. Thanks again, everyone.